Hello students, welcome to lesson 2, which is interpreting division of a whole number by a fraction, again using visual models. Our goal is to use visual models such as fraction bars, number lines, and area models to show the quotient of whole numbers and fractions. We also want to use the models to show the connection between those models and the multiplication of fractions. We want to understand the difference between a whole number being divided by a fraction and a fraction being divided by a whole number. So yesterday's lesson we had a fraction and we are dividing by a whole number. Today is the opposite. So let's go ahead and begin with example 1. Please make sure that you have your composition, your interactive notebook ready with your notes. If you don't have that ready for taking notes, please pause the video until you're ready to take notes. Example 1 says, fill in the table below by either writing it as a division question, writing it as a multiplication question, making a model to represent the question. So what we're going to do is look at our original question here. We're going to write it as division, we're going to write it as multiplication, and then we're going to write the question given to each group as a multiplication question. Number 1 says, how many half miles are in 12 miles? So let's stop and think about this realistically. If we had 1 mile, and I wanted to know how many half miles are in 1 mile, you would tell me 2. 1/2 plus 1/2 makes 1 whole. So there would be 2 half miles in 1 mile. So if I have 12 miles and I want to know how many half miles would be in 12, well, there's 2 in each. So what I would need to do, I can first write this as 12 divided by a half, but really what we're going to have to do is 12 times 2 to see how many half miles are in 12 miles, and the answer would be 24. So for the question, what we're trying to figure out is really 1/2 of what number, abbreviate, is 12. Well, if I ask you like that, half of what number is 12, you could tell me, well, half of 24 is 12. And that's exactly what this fraction, when we're dividing, that's what we are doing. Let's look at number 2. How many quarter hours are in 5 hours? So our division question would be 5 divided by 1/4. If I were to write a multiplication question that this would answer, well, if we're thinking about quarter hours are in 5 hours, well, how many quarter hours are in 1 hour? Well, you have 15 minutes, 30, 45, and 60, so that would make 4 quarter hours in 1 hour. So if we have 5 hours, we would want to multiply 5 by 4, because there are 4 quarters in each hour. So if I'm trying to think of a question given to this group as a multiplication question, I would say 1/4 of what number is 5? Number 3. How many 1/3 are in 9 cups? So how many 1/3 cups are in 9 cups? So I'm going to divide my 9 by 1/3. And so again, same thing like the previous 2. How many 1/3 are in 1 whole? We have 1/3, 2/3, 3/3. So there are 3 in each cup. So if I want to try to figure out if I have 9, I would do 9 times 3. And that would give me my answer of how many 1/3 are in 9. So again, when I write this as a question, I can say 1/3 of what number is 9? 1/3 of 27 is 9. Number 4, how many 1/8 pizzas are in 4 pizzas? So if I have a pizza and it's split into 8 slices, how many 1/8 slices are there in 4 pizzas? Well, if you split it into 8 slices, then there would be 8 in each pizza. There would be 8 slices of pizza. So if you have 4 pizzas, let me go ahead and do our division. We're dividing the 4 pizzas into 8s. So you would multiply 4 times 8. And so our question would be 1/8 of what number is 4? 1/8 of 32 is 4. And our last one for right now, how many 1/5 are in 7 holes? Again, if you think about how many 1/5 are in one hole, 1/5, 2/5, 3, 4, 5/5, there would be 5/5 in one hole. So let's go ahead and divide 7 by a 5th. So if there's 5 1/5 in one hole, then I would go ahead and multiply 7 by 5 to get how many 1/5 are in 7 holes. So again, my question is 1/5 of what number is 7? And the answer again was 35. All the problems in example 1 show measurement division. When we know the original amount and the size or measure of one part, we use measurement division to find the number of parts. You can tell when a question is asking for measurement division because it asks how many blanks are in blanks. Our next example, example 2, says Molly used 9 cups of flour to bake bread. If this was 3/4 of the total amount of flour she started with, what was the original amount of flour? We want to create a model to represent what the question is asking for. What I'm going to do is a tape diagram. Also, you can refer to it as a fraction bar like we did in the previous lesson. If Molly used 9 cups of flour to bake bread and this was only 3/4, I'm going to go ahead and show 3/4. This is the 3/4 that she used. And she used 9 cups of flour to bake the bread. That was 3/4 of the total amount of flour that she started with. So this right here, the 3/4, is 9. So if 9 is these 3 boxes equally, we need to divide 9 equally amongst the 3 boxes. So if you think about 9 divided by 3, we should put 3 in each box. 3, 6, 9. If I put 3 in those boxes, what do you think I might want to put in this box? Another 3. So that means that the original amount of flour that she used was 3 by 4, 3 times 4, or 3, 6, 9, 12. So the answer would be 12 cups of flour. Another way that I could do this, it's pretty similar, but just slightly different. I'm also going to have 3 out of 4. But this time, if this is 9 right here, I can go 3, 6, 9, and put my 12 at the end, counting those. That would be an example of the tape diagram compared to the fraction bar. So again, the answer is, what's the original amount of flour? That's our question right here. And the answer would be 12 cups of flour. Please make sure that you do your reflection by asking a question or writing a comment, and then also rate yourself on how you feel after this video. And if you're able to, create your own example. It could be a story problem, it could be with just the numbers, and a model explaining your answer.